Hello everyone. In this video, we will see how we can use Atom to create multipoint-to-multipoint Ethernet services that transport all traffic on an entire port across a BGP network core using Ethernet vpls as a physical encapsulation type. We can limit the bandwidth of services built from this service definition to specific values from 10 Mbps to 100 Mbps. We will also provision the connectivity fault margin profile for the service. Atom offers predefined service definitions in the form of a profile that one can choose from to create a particular service. The profile captures the commonly used parameters in a service. You can either edit them or you can create your own variation. Let us take a look at the service definition for port-based Elan service over BGP signaling. Here we can see that the service type is set to Elan multipoint-to-multipoint. The instance type is set to vpls and the signaling protocol is BGP. The route target and the route distinguisher is set to autopick and is pointed to a profile on Atom's resource manager under IPAM. The MAC learning is set to true. The PEC interconnect has the following settings. The VLAN tagging is set to port based and the physical interface encapsulation is set to Ethernet vpls. The VLAN normalization is set to normalize not required as this is a port-based service. The rate limiting is enabled and can be changed during the service creation. The QoS is enabled as well. Let us now try to create a service. The template is already imported. The initial set of parameters include the service name and the customer. The service definition is set to Elan BGP port based, which is the profile we just reviewed. Rest of the parameters will be taken from the profile itself. Since we have chosen normalization not required, no VLAN tags need to be entered. The CFM template is selected from the CFM profile. The site settings capture the PE details. The device IP and the interface connecting the CE can be seen here. Since this is port based, we have chosen unit ID as 0. The class of service template is chosen from the cost profiles. Similarly, we can create other nodes involved in the Elan service under the different site settings. The node settings capture the MAC learning details and the details such as RD and the RT values if it needs to be overridden from what we have as part of the Elan profile. Let's try to create the service now. As you can see, a new service has been created. Let's take a look at the tasks to see the provision commands. The initial configuration includes a class of service configurations. We can see the forwarding class is set to best effort and the code point associated is shown as well. The forwarding class is mapped to Q0 to forward the traffic. This is based on the class of service profile. We can also see the scheduler configuration linked to the queue to regulate the priority, buffer size, transmit and shaping rate. The configuration related to interface linking to class of service is also seen here. Rest of the configuration includes firewall and policy configuration, encapsulation configuration, and CFM configurations. We can also see routing instance configuration including the route distinguisher and route target configurations and the MAC learning configurations. On the device, we can see the routing instance configurations including vpls protocol configurations. We can also see the route distinguisher and route target values. The interface configurations capture the encapsulation details and the firewall and policy configurations. Since this is port based, there is no VLAN translation configuration seen. We can also see how interfaces link to the scheduler maps and classifiers. We can also see the class of service configuration that includes DSCP configurations, forwarding class configurations, and scheduler map configurations. We can also see the CFM configurations based on the chosen CFM profile. Thanks for watching.